Yo, hey everyone, welcome back to the fourth episode. Sorry about last episode's quality of the mic. I will try to fix it. Hopefully, it's better this episode. And with that out of the way, let's get into it. So, this episode, I'm not going to be talking much about code. We won't be coding that much. Next episode, I will talk about batch rendering, and we will be getting batch rendering to work. Maybe finishing it up in the fifth and sixth episode. Sixth episode. But yeah, in this episode we will be talking about element array buffers and how a batch rendering works. Right. So in the second episode, I believe we talked about vertex buffer objects and how to send data to the GPU. Great. But if you noticed, when we try to draw a second triangle here next to the first triangle to form a square, you may have noticed we're reusing 2 points, the first point and the third point. How do we prevent this? Well, instead of having 6 points, we can have 4 points and having an index buffer. An index buffer, or an EBO, essentially tells the GPU what order to render each vertex in. Right, so we can have vertex 1, 2, 3, 4, 5, 6, 7, blah blah blah, but we can tell it to start from vertex 4, vertex 1, and vertex 2, vertex 4. You get my point. It tells the GPU what order to render it in from the giant array of information. That will prevent stuff like this, where my mouse cursor is right now. And a batch is essentially just a tile map, a big tile map of collection of, well, vertices and indices, and it's just one buffer. And we do this generally to save performance, because each VBO and EBO and VAO needs memory in RAM, and that, well, can pile up quickly if you have like 25, 100, 150, 500 tiles. So in generally, we like to store that in one. So let's actually get down to coding a EBO. It's quite similar to a VBO, but instead of creating a VBO, we create a EBO, element array buffer. And we do have to change some parameters. So first of all, let's use a EBO instead of VBO. Then we have to change GL array buffer to GL element array buffer. And instead of sending vertices, we will send indices, with of course the size being GLU int, since it's not sending any data but rather just, order or numbers, which vertex to draw at what point. So if you have noticed that there's a mysterious indices array, that is true. There is, and it's right here. Vertices and indices. I did change the vertices array a bit from 3 vertices to 4 vertices, adding a mysterious third or fourth vertex. Simply has the x value to 0 and the y value to 1. As for the indices, the type is GLU int because it's telling just what order, doesn't need any information. And the indices array will consist of 0, 1, 2, so these 3 vertices, and then 0, 2, 3, 1, 2, 3. Now, to actually use this, we can't quite just use GLDraw arrays. What we have to do is use another function called GLDraw elements. Here are the parameters. The first stays the same. Mode stays GL triangles. The third stays, well, a bit the same. It's converted to 6 instead of 3 because we're measuring the indices count right here, not the vertices count. Second is type. We can put GL in unsigned int, which is the type of indices, not the vertices. And finally, indices. Not buffer, the parameter we can leave at null, which is deprecated. With that done, we should be seeing a square. And we're not seeing anything. That is because we have to move this below the VAO. This has to be created after the VAO. And I forgot to change one very important thing. Instead of 3 vertices, in the VBO, there's 4 vertices now, so we have to change this to 4 instead of 3. And now when we run this, we should be seeing a square. Yippee! Square! Next episode, I will talk about batch rendering and how to get many of them, including orthographic projection and matrices. Hope you guys enjoyed this video. Good luck. See ya. Bye.